All right, we just want to practice more of this verifying trig identities. Just practice, 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 right? It's a thought process. So here's example 2. We're going to verify this trig identity of cotangent x sine 2x, so they're multiplied together, equals 1 plus the cosine of 2x. Now, when you go through this, you want to just be thinking, okay, how can I work with what I need? What do I need to do here, etc. Where you're going to start with this, start here, because if I'm looking at these two sides, sine 2x has one formula. Cosine 2x has 3. What? Right? I don't know which one I'm going to use. In lieu of just trying a whole bunch to see which one plays out, start over here with the path of least resistance, if you will. Something that is easier to work with. So because sine 2x only has one formula, then let's put this in terms here of sine and cosine. So I'm also going to convert cotangent here to also be in terms of sine and cosine. So cosine x over sine x, and then 2 sine x cosine x, and I'm not going to mess with this side yet. But look at what just happened. Now, if I have my sine on the bottom, cancels out the sine on the top, right? Because it's a fraction. On this side is the same thing as over 1. I'm going to change this up. This is the same thing as over 1, right? So my denominator and my numerator, because everything is multiplied, that's fair game. If it had any pluses and minuses in there, then that wouldn't work. But now I have my cosine here and my cosine here, so I've got a cosine squared. So let's see what this is. So now I'm left with 2 cosine squared x is equal to 1 plus cosine 2x, right? Now that I'm working back through this problem, as soon as I see this cosine squared on this side, that is my tip-off. Now I know which double angle cosine to use. Because of the cosine squared right here, I'm going to use the double angle formula for cosine that deals with cosine squared. So I have 2 cosine squareds of x is equal to 1 plus, and then my formula is 2 cosine squared x minus 1. That's my formula. All right, now look at what just happened. Plus 1 minus 1. Cancel out. 2 cosine squared x is equal to 2 cosine squared of x. Remember, when you verify those trig identities, you're not trying to solve for anything. You cannot go back and forth across that sign. Okay. Let's do one more. We should have room. Let's try it. Let's try it. This is an example. I'm just coming up with one from the back here. So verify this identity, because it's good to practice these. Sine squared x secant squared x plus sine squared x cosecant squared x equals secant squared x. Now, the first thing that I'm looking at here is those. So this side's obviously crazier, but the first thing I'm looking at is those automatically cancel out. That's amazing. And this secant squared with this sine, I'm going to go ahead and make the conversion on this secant squared. Oh, I just saw it. Okay. So if I make this conversion, I now have sine squared x times 1 over cosine squared plus sine squared times 1 over sine squared. Do you see it? Are you looking those 2 steps ahead? So this cancels out to give me a 1. Doesn't cancel out, nothing's there, right? I still have this plus sign. So I have to have something back over here. So this is just that plus 1. But look at what's happening here. Sine over cosine. What's sine over cosine? Yep, tangent squared x. And do you see it? Do you see it? Because this is like over 1. Secant squared x equals secant squared x. That's that Pythag identity. Some of these start out looking super craziness, but then when you start just